welcome to our July Xoran webinar on intracerebral hemorrhage, real-time evolution as visualized using Xoran's truly mobile xCAT IQ. Thank you for joining us this afternoon. A few housekeeping items as we head into the webinar. Please remember that we will send you a recording of the presentation within the next week. We generally like to wait till we received all your questions and can answer them when we send you the recording. And also, please remember that you may submit questions via the chat function. There is an orange highlight shown at the bottom. Questions will only come to me as your co-host, and I will read them out to Dr. Gormley during breaks during the presentation. At several points in time, if you have additional technical questions, we have our product management team on the call who can answer those questions, and I'll be more than happy to defer those questions to them or answer them as we can. As always, for more information about the xCAT IQ and Xoran's products and services, you may visit our website at xorantech.com. Our guest speaker today is Dr. William Gormley, a neurosurgeon and critical care physician with over 30 years of medical experience. Dr. Gormley is a great friend to Xoran Technologies, and he is a healthcare innovator with a deep understanding of medicine and the ability to rapidly evaluate the clinical value proposition, adaptability, and scalability of new healthcare technologies. Dr. Gormley serves as Director of Neurosurgical Critical Care at Brigham and Women's Hospital in the Greater Boston area, and we are excited to have him on the call with us today. Also on the call with us is Russell Yonke, our Director of Product Management, as well as Robert Snow, our Product Manager for the xCAT, and they'll be taking your technical questions. Russell, would you like to say a few words before we turn this over to Dr. Gormley?
Sure, thank you, Ramade. I just really want to say thank you to everyone for being on the webinar today and taking their time out of their day to participate in this. And, you know, this is a huge honor for Xoran to have Dr. Gormley host this webinar, and we're very thankful to him for his time out to put forth this webinar, and it was a very great idea on his side to put this together. And we're very fortunate to have been able to work with Dr. Gormley over the last couple of years on many fronts, and this is just one example of the advances that we're working toward with that relationship with Dr. Gormley. So thank you very much, and I'll turn this back over to you, Ramade.
Thank you, Russell. So, Dr. Gormley, thank you for hosting us today and speaking on this topic. If you're ready and would like to say a few words, we're ready to begin.
Thank you, team. Welcome to everybody. Hopefully we can make this a very interactive session. If you have any questions, you can address them quickly. Now, before we start, I should just say, obviously these studies that we're going to show you are done on a cadaver, so not exactly what you're going to be facing, but we thought we would get a feel for what advantages we could have using a mobile CT scanner at the time of placing an EVD in this particular situation. So we can start out with the next slide. That would be great. Okay, so if we think about what we do every day, we face somebody who needs a placement of an EVD. It turns out that this cadaver actually did need an EVD. So it was quite fortuitous. So what do? We use our traditional landmarks. We go 10 centimeters back from the nasion, 3 centimeters lateral to the midline. We all know we've done them 100 or thousands of times. And for the most part, we have no image guidance. You know, we can do these in the operating room, you know, but image guidance is so problematic and so time consuming that, you know, to expect us to do them in an emergency setting, such as the ICU or the emergency room with guidance, that's just not going to happen. So we know we don't have guidance. We know we're using landmarks. And we don't really know where it's going to end. If we get some CSF out, that's a huge victory. So I think that's kind of what our hope is before we start. And then afterwards, the question is, Do we get a scan? Do we not? Depends on where you are. Certainly in Europe, they do not. In the United States, we do always, at least in our setting. Not sure if that's actually a great idea, but that scan isn't immediate. That scan is usually done within the next couple of hours. And by then, we're off on another task, so we never really get to see that scan in real time. So that's kind of our traditional case. Let's go through what that looks like in this setting. We'll go to the next slide, please. Okay, so we put in our EVD, and yep, we went too deep. We went contralateral, so we started from the right frontal area. We went past the ventricle and ended up in the internal capsule of the opposite side. For the most part, we wouldn't know this because the only thing we do know is that we're not getting any CSF out. We don't know where our catheter ended up. Sometimes, actually, we can be in this location and actually get some CSF out if some of our distal catheter perforations are in the ventricle. So we could have this catheter location draining CSF and still be a real problem, right? So this is bad enough because in the internal capsule, obviously we can cause hemiparesis and hemiplegia, but let's imagine that it actually gets worse. So next slide. Okay, so this is our nightmare, right? We've gone past the ventricle, we've caused an intracerebral hemorrhage. We probably won't know about this until the patient really starts to deteriorate. Lots of these patients are not doing great to start out with, so for us to notice the deterioration, it actually has to be quite a dramatic deterioration, right? So if they're somnolent to start, and we gave them some sedation to do the procedure, we put in the catheter, we get a big hematoma, and we just don't know because they're not waking up quickly. This is one of the huge advantages of actually having a scan there. You scan the patient immediately after you place this. You can use the scanner to place this, and then immediately after the placement, and you'll know right away. Is it in the right place? Have I caused a complication? So that is the thought of having the advantage of a very mobile bedside scanner. Go ahead. Okay. So. And here, obviously, we see that we've created a massive intraventricular, massive subarachnoid hemorrhage in this patient. And obviously, the question for all of us is, if we had some guidance, would this have happened? And the answer is probably no. And is it advantageous to see what we've done, even if we didn't have guidance? Would it be advantageous for us to be able to say, okay, I know what I've done, I know where I am. So the answer is yes to it would be important to know what we've done immediately, but it would even be more important if we actually had a system to guide us while we were placing this. So that's what we want to think of in the second part of our presentation. What would it look like if we had actually done this with guidance? So that's actually the catheter placed correctly. Why don't we go on to the next slide? Okay, so this is what every one of us does, what every one of us has done for, in my case, 30 years, but in the case of neurosurgery overall, for 50 years that we've been placing EVDs relatively blindly. And although this is one of the major areas of complications for our patients, because it's not particularly sexy, nobody really focuses on this, right? If we actually focused on the morbidity we create with this procedure, we would be much more interested in making it better. So that's the thought that brings us to our better case. What should we really in 2020? What should we be expecting of ourselves using technology? So let's go through that. Okay, so this is the scanner. Very, very small. Obviously, we can scan the patient quickly in pretty much in real time have a scan that tells us where we are, right? So that's the preoperative scan. Now, knowing the preoperative scan at the time of placement is super useful. So that's what it looks like, pretty much the scan that we had previously. Now, what would it look like if I was getting guidance for this? Keep going. Next slide, please. Okay, so this is going to bore most of you because we've all done this hundreds of times, but we're going to take our regular landmarks. We're going to go 10 centimeters back from the nasion. We're going to go 3 centimeters lateral. We're going to make a stab incision, and we're going to make our burr hole. So this is what we always do. Nothing changes. This is what we did in this patient, actually. So now we place our burr hole. Okay, so now we can see where we are. You know, on the surface of the skull, we can see exactly what that looks like. And then we go ahead to our burr hole. Next slide, please. Okay, again, using the standard EVD, we don't need anything special. We don't need you know, any of the optical guidance systems. Now we've made our burr hole. We can even check to see what our burr hole looks like. Actually, as many of us know, an improperly placed burr hole that's too skived in one direction or another actually guides our EVD placement. So if you put your burr hole in wrong, your EVD is going to go in wrong. It's just as simple as that. So we can scan to make sure before we put a catheter in. We can scan to make sure. Okay, let's make sure that our burr hole is in fact where we want it to be, and it's in the direction that we want it to be. That it is perpendicular to the skull. And there we have a picture of that. We can see we're through. It's perpendicular. I can see the ventricles. In fact, this is I'm on the right trajectory. So that is super helpful, and I can know that as soon as I'm doing this. Okay, keep going. Then we do what we always do. We place our EVD, get flow of CSF. Needless to say, we didn't get flow of CSF in this case, but you know, we can if we think about what we can do with this scanner, we can actually, if we wanted to, and I'm not recommending this at this point, we could actually watch ourselves go into the ventricle, much like CT guidance does in any other part of the anatomy, like our CT guided interventional teams do. Okay, keep going. So there we are as we are inserting the catheter. The catheter is going into the frontal horn. Next slide. We'll watch it going in a little bit further. Next slide. And then we get into the ventricle. Once we obtain CSF and we know that we think we know we're in the right place, we get a new scan to demonstrate that in fact we are where we think we are. And sure enough, you know, that is the picture that you'd seen previously, but this is what our outcome is always intended to be. We know we haven't caused a complication, we know we're in the right place, and we know it immediately. So I think that that changes dramatically the way we approach this procedure, and hopefully will mitigate a significant number of our complications that, as you know, are somewhere, depending on the report, between 40 and 40%. So between 4 and 40%, sorry. So a huge range, but a really, it can be very devastating complications from this. So what we're suggesting is that to use this scanner at the bedside will make things significantly better and much more timely, particularly in the case of complications. that is pretty much what we've wanted to present at this point. We have, you know, in the recognition that surgeons don't like to be looking at screens, we are developing a system that we were actually going to present at CNS in October. But we're developing a system which basically utilizes the bedside CT with a guidance system right at the site, which will guide the catheter placement based on the scan that you just did a minute before. So we think this will make things even better and will give us a real-time, you know, sub-millimetric accuracy for placement of these EVDs. And we'll do it without, you know, mobilizing the whole operating room team to come and help us with optical systems. So that's where we're at this point, and I'd be happy to entertain some questions or thoughts from anybody.
I don't have any questions in the chat room, so Dr. Gormley's on and ready to answer questions about the process and procedures we just went through. If you have any questions about technical, Russell and Rob are also able to answer those questions, so you may come off mute and ask those at this time. So I have a question, Dr. Gormley. In your opinion, how easy is patient positioning with this device?
Oh, it's exactly like patient positioning for any EVD. Obviously, there's the slight variation that you have an extension for the head, but that's, you know, you're basically just moving the patient 2 feet up or 1 foot up from where we traditionally have the patient in the bed. So once we do that, then the rest of the procedure is exactly the same.
Okay. Another question we received is, how concerned are you about the dose given to the patient?
That's a terrific question. You know, these scanners, and you will have to ask people who are more technically adept than I, but just believe what I say, because this is what they told me. These scanners, the dosimetry on these scanners is about half the dose of a regular CT scan. So that wasn't really the answer you asked. How important do I think the dose is? Very, very important. Does it make me feel better about the fact that these scanners, a full scan has half the dose of a regular scan? Absolutely, right? It's a much more useful thing. Given what we are developing, which should be you know, available reasonably quickly, we will be able to do one scan right up front, use our guidance system without obtaining another scan, place the catheter, and then, depending on your practice, get a surveillance scan right at the bed or not. So overall, I think that this doesn't add radiation, and if we compare it directly to current scanners, it's actually less radiation if you do a pre and post scan. Excellent question.
Okay. The next question is, where can the xCAT IQ be used in the hospital? And how long does it take to do a scan?
Oh, what a great set of questions. Okay, so you know, I think that the beauty of the xCAT is that it is so mobile. We have gone, I don't mean to trash other devices because I don't actually work for the company, so let's just be clear on that. We have had some of the other mobile CT scanners. They are really gigantic in comparison to this. And by those, we're talking about the Siemens and the Neurologica, now Samsung devices. They're much, much larger. These things you can wheel around, and so we use them in the ICU. We use them in the operating room. So, you know, really, its mobility is one of the huge advantages of this, and the ability to say, you know, I don't need a scanner for that can only serve my ICU or that can only serve the OR. I can actually move it around, particularly if you've got a smaller hospital where that is kind of a prerequisite.
Okay. The next question was, how long does it take a scan? And I think
I didn't answer I wasn't being evasive, I just forgot. So now somebody who's smarter than me can correct me, but the beginning of scan to picture, it's 5 minutes. If I'm wrong, please correct me. But I think that is an accurate statement.
Dr. Gormley, this is Russell Yankee, Director of Product Management at Xoran. Yeah, you're really close. It may be even less than 5 minutes, depending on the setup and who's involved and those types of things. But the scan itself takes 45 seconds, and then it takes a little more than a minute, sometimes 2 minutes, to reconstruct the image and have it available right there on the device.
Actually, I'm sorry, I did know that. We did a lot of scans when we were putting this together, and I do remember it's 2 minutes. So there you go.
The next question is, would a CT fluoro help with the catheter positioning similar to what is used on conventional CT?
Would a CT fluoro, you mean sort of an active CT? Is that the question?
I believe that's the question they're asking. Yes.
So the answer is yes. What we tried to demonstrate was that that's what we were doing, right? We were advancing a bit and then checking the picture. And it turns out that the reason why we're developing, sort of a stereotactic addition to this, which is, used super simple, used right as we do the scan, is because we're not interventionalists, we're surgeons, and we just want to put the catheter in, right? And so we want somebody to tell us, this is the direction, this is the angulation, put in the catheter. And that is what our device is doing. It again, it's fairly advanced. We didn't. Again, I mentioned it was to be ready for a CNS meeting in October, and maybe we will have something more to expand on that later. But I think that the right answer for this procedure is just to have the CT scan, a small stereotactic device that uses the CT scan that you just obtained, and just a straight placement. And that's what we're actually developing. But could we use the CT as a sort of a fluoro CT during placement? The answer is yes.
There's another question that just came in. Dr. Gormley, when deciding on requesting the CT scan on a patient, does moving the patient from the ICU influence your decision to order one? That's your decision to order a CT scan.
There's no question, right? I think that there's a positive to that and there's a negative to that. And obviously, we should focus on the negatives because they're negatives to our patients, meaning, if we think that the patient's too sick, too unstable, we just don't scan it. And we've had patients that we wanted to scan, but we haven't scanned for 3 or 4 days, particularly if they've got significant other system trauma and cardiovascularly they're unstable, or respiratory-wise they're unstable. They can't be moved off of their current ventilator settings, and we just don't scan them, and that obviously is a bad outcome. So we use it in the ICU and basically scan when we feel it's necessary. Now, the correlate to that question is, do we find ourselves scanning people like all the time? And the answer is no. But the temptation is to just say, oh, look, I've got a question. Why don't we just scan them? I think that's just good medicine if you avoid that, right? These aren't toys, but it does make it much more available, and it makes it much safer for patients to be able to scan them in the ICU.
So the second part of that question, bearing in mind that the first part was, does moving the patient from the ICU influence your decision to order one? How often do you decide against it because of moving the patient?
Again, it depends on how sick the patient is. So it's kind of an imponderable. you know, if you have the mobile CT scanner, it turns out that we just don't send them out as much. But that's really the answer that makes a difference. Whether we would have gotten a standard scan or not in the past, we just don't send them out. And so the nurses love that, the respiratory techs love that. And at the end of the day, it is safer for the patients. But when is it absolutely prohibitive to take them out? If I said 5 to 10% of cases, I think that would be accurate, but I'm not, you know, I don't have that fact.
So we do have one more. So with proper guidance, do you think someone other than the neurosurgeon could place the EVD?
What I was wondering when somebody was going to ask that question. You know, I think that we're, so the answer is yes, of course, right? Of course that somebody that's not a neurosurgeon can place these things. As a matter of fact, in our setting, we are training our physician assistants to place these catheters. So, and in a previous setting, when I was in Texas, this was 15, 18, 20 years ago, our physician assistants were already placing the catheters. So to extend from that to can a general surgeon place it? Sure, of course. And if they have guidance, will they actually do it because they feel more comfortable doing so? The answer is yes, of course. I don't think that exclusivity is something that's going to remain.
Okay. I believe that was the last question we had. Does anyone else have any additional questions for Dr. Gormley at this time? Or does Dr. Gormley have anything additional to share based on the questions you've answered so far?
I don't, actually. I think we've covered all of the advantages that I see and sort of where I think we should be viewing what is an acceptable risk for a patient in 2020. And, you know, to have the technology available and to continue to do things the way we have for the past 50 years with pretty significant complications is not, to me, an acceptable outcome. So we're working hard to resolve that issue.
Okay. Well, thank you, Dr. Gormley. We do really appreciate your time. As always, everyone, if you currently are considering the benefits of the truly mobile xCAT IQ and more about the topic we discussed today, as well as some more insight, you can always call 800-709-6726 for questions, and of course, XoranTech.com. Also on XoranTech.com, on the news and events page where we've highlighted this webinar, Dr. Gormley also shares a white paper that he co-wrote last year related to this topic, and we encourage you to read that. We will also share that again in the recording when it's shared with everyone later on this week or the beginning of next week. As always, thank you for joining us today. Xoran appreciates your time, and we look forward to seeing you soon. Thank you, everyone.
Thank you. Have a great afternoon.
Thank you, Dr. Gormley.
Thank you, Dr. Gormley.
Thank you.
Thank you.